I mentioned 0.5. 0.5 is our the middle of our texture. I neglected to mention that this whole thing that I've been going over just now with like these curves, this only describes one dimension of my like texture. So this x-axis, this represents a UV coordinate component. So either U or V, either X or Y in the texture. Okay, hold on. Now let me collect my thoughts here. Let me figure out what I want to say. If I want to like make some kind of transformation between like the normal like UV coordinate space, which is literally just this. It's 1 to 1. So like if I get a UV coordinate component of 0.3, if I don't do anything to it, if I don't map it like to a curve or like manipulate it in any way, I'm just going to be getting the texel that is at the UV corresponding to that 0.3. Whereas if I map it to something, if I map it to some other value, then I'll be getting some other value, and that's what this graph is describing. But it's only describing it for one component at a time because that's all this graph can accommodate. Because in order to consider both the U and the V, I would need a three-dimensional graph. But anyway, let me see here. What was I saying before? So I got so excited because I thought this was what I wanted, and I didn't even stop to think about the fact that like I was too obsessed with like yes, this is what I want to happen. As I get closer to 1, I want to follow this side of the curve, except on the other side. But what's really happening here, even though it fits my intuition, like visually, I guess, what's really happening here is after I get to the center of the image, as I start getting further and further away from the center, I start basically drawing these pixels over here. I would basically start like mirroring the texture, because like okay, so uh remember this is for one dimension at a time. So let's say I got a U component 0.333. That will map to somewhere around 0.4 or whatever. So on this, that would be somewhere over here. So basically, like once I get here, once I get here in the once I get right there on the first part of the graph, I'll basically be reading from the texture pixel right here at this point in the graph. But then once I get over to this side of the graph, and let me see, where was that? Over here. Once I get to this point in the graph, you'll notice that the value that I get back for that is around 0.4. So basically for this point right here on the other side of the texture, I'll also be reading from this same pixel over here, and that's not what I want. What I want is to read basically from this pixel over here, because this is on the other side of the texture, or like right here, the diagonal, I guess. um, the middle of the texture. So yeah, that's what happened there. I got overly excited, and then I did not observe the results that I was expecting, because I completely forgot. Oh wait, I'm literally just copying the other side over here, so I have to do something about that. I have to somehow take this exact curve right here and then flip it so that like it starts coming out on this side, and then goes up, and then like starts tapering off above the diagonal. Um, so yeah, so that that was kind of tricky. I'm not sure if I can remember my exact thought process behind it, but if I did what I'm thinking now, I probably would just say, oh, what does it look like when I take the additive inverse? Okay, so that I think that does what I want it to do, because like right here, if we just took this half and kind of slid it up here, that does what I want it to do, because like it comes out to the right, and beneath the diagonal line, and then at some point, like it starts going up, and then at some point it crosses, and now it's above the diagonal line, and then it starts tapering off to the proper UV component value. So yeah, that's probably what I did. I probably honestly at this point I probably just started like adding random like coefficients and offsets and stuff. So I guess for brevity, I'm just gonna go ahead and move to the next like part, which is this. So basically just the additive inverse, offset, and yeah. So cool. Now, this was kind of a bit of a like a checkpoint almost, because like this does it. This achieves the mapping that I wanted to achieve. So like, we start off slow, and then we get more intense, and then we're at our most intense, and then once we get to the other side here, then we start. We're still intense, and then we gradually taper off, and then look, as we get closer to one on the other side, we start getting closer to one on the other side, instead of zero. So we're not copying the pixels from over here. We're reading the ones over here now. So yeah, that's cool. But the thing that's kind of inconvenient about this right now is that we have two curves. So basically in the shader, like source code or whatever, we would have to, like, since we have these two curves, I mean, there's no way to make this follow both of these curves, because if I applied the UV to this curve, then it would start giving me these values. Um, and then same thing over here. If I just did this, it would start giving me these values. One solution could be to just have like an if statement where if the UV component is less than 0.5, then I'll use this curve, and if it's greater than 0.5, then I'll use this curve. But I try to avoid branching whenever I can, just because it makes things complicated. When you can describe a mapping or a transformation or something using one continuous function, I don't know, something about that just it gives me a warm fuzzy feeling inside. Um, yeah, and then this is when I kind of got into the weeds a little bit of like you know like trying to find the most like elegant way to do this, and like sometimes like you come across like some unsung heroes of like standard libraries and stuff. I'm not like a big like GLSL or OpenGL in general expert or anything like that. Um, but uh, um, but I do notice that there's a lot of things that like that that the standard library, I guess, for GLSL doesn't have, that like I'm so spoiled with other like math libraries and things that I'm like, oh my God, how could you not have a random function, and stuff like that. But honestly, there's like some real unsung heroes that like you wouldn't think are super like versatile and useful, but like, man, this sine function, it really saved my life. Um, so let me see if I can step through my thought process on this, and if I can't, I'll just if I can't like recall it in an easily digestible, coherent, concise way, then I'll just put the curve on there and you know move on, I guess. Okay, so let's see here. CK. I'm gonna start with CK. Going to start with CK, and then what I'm going to do is um, I am going to just sort of remind myself what the additive inverse looks like. Okay. Um, and then I probably, I probably noticed at this point that I can. So basically, what I want to do is with this side of the curve is I want to say, okay, do all of this, and then as soon as we hit 0.5, just ignore everything else. Um, because like my goal will be, my ultimate goal will be to combine these two curves, most likely add them together in some way, add them together. And when I add them together, I want to make sure that the stuff on either side, that corresponds to the parts that I don't want, that they won't affect the other curve. So basically, if everything on if everything on this side of the 0.5 on this curve was 0, and I added it to this curve, that would mean that on this side, all I would have is the values from this curve, because like 0 added to this curve is just this curve. So yeah, that's probably how I started thinking there. Another unsung hero, min and max, incredible. Yeah. So trying to remember how I stepped through this. Okay, so let's see. So yeah, once I get to this side, I basically want this to be 0. So what I could do is I could take the minimum of 0 and something here, something that I know will be greater than 0, once it reaches beyond this 0.5. Um, and and one thing that we can do, since all of these are based on this L variable, which is just x, which is just our UV component. One thing that we can do is we can use that in this in this function. So we can say the minimum of 0 and x, or our UV component. So actually, let me just see what this looks like real quick. So minimum, oh wait, what am I doing? What the heck am I doing? That times minimum of 0 and L. Let me just see what that looks like. Oh man, that's not pretty. That's not pretty at all. This is doing some stuff over here, and then as soon as we were crossing 0, it's like, it's, we're basically, all the rest of these values are just 0. Um, and I don't want that at this point. I want that at this point. So what I could do is I could say, um, yeah, okay, so I want to take the minimum of 0 and our UV component offset by some amount. And the amount that we want to offset that by is negative 0.5. So basically, like, um, when I'm at point 0, I'm going to subtract zero point 0.5, and then I'm going to take the minimum of 0 and negative zero point 0.5, which is going to be negative zero point 0.5, and then multiply that by our curve. But the thing is, that's a little bit wonky. It's kind of messing up our existing curve. Hold on, let me just go ahead and put that there, so I remember. So I know that we want to offset it by this amount. Yeah, I remember seeing that too. Um, but yeah, I know that I want to offset it by this amount. The thing is, though, so we're getting back like this negative 0.5, and multiplying that by our nice curve here that we spent so much time trying to figure out is messing up that part. So what we really want to do, is not just take the minimum of these values and then just multiply by our curve. We just want to say, if it's beyond a certain point, multiply it by 0 to basically just discard it, like completely, get rid of that side of the curve. But if it's not, we just want to keep it the same. So multiply it by itself, or no, I'm sorry, that was a dumb thing. Multiply it by 1 to get itself, as the result. So multiply the curve by 1. Yeah. So, and that is where the sign comes in. So, we say sine that. Yeah, yeah. That looks nice. See, that's where 0.5 right there, and then you can see the 0. Yeah, and but we got to make one little change here, since the curve is below the x-axis, then that means that we need to take the additive inverse. And right there, all right, so we're back to our original we're back to our original curve, but with everything beyond that 0.5 just totally zeroed out, so we don't care about it. So cool. Um, yeah, and then the next thing that we got to do, is do that for the other side. Okay, so oopsies, spoiler alert. Yeah, so basically with this, the thought process here isn't very much different. It's just like, okay, so we've got CJ, and then I know that I want to keep using the sign because we basically want to get something. We basically want to get a 0 or a 1 to multiply the curve by. So I know that I want to keep the sign because the sign that'll get me the 0 or 1 that I'm after. But here's where it kind of gets a little bit tricky, that I kind of have to think about, like, what do I really want here? If we take the um, if we take the minimum of 0 and x, or our UV component, then we'll always just get 0. Oh wait, hold on. Oh wait, no, hold on. Let me take the offset. I forgot to factor in the offset. Here, let me just start basically from where the other curve was, or where the other function was. So yeah, we kind of get a similar thing going on here. Minimum of 0 and L minus 0.5. 0.5. So be okay. So for 0, it'd be negative 0.5. Okay, if we take the minimum of that, it's going to be 0.5, negative 0.5. We take the sign, which is negative 1, multiply that by our curve. Aha, yeah. Okay, so that, yeah, and you can see that it's resulting in the additive inverse of our curve. So what we want to do instead is we want to say, I'm sorry. I know that I have all the answers right here, but I don't want to. I want to try and avoid just saying, "Oh yeah, this is the answer," just because. I kind of want to arrive there, so that it's not all like smoke and mirrors, I guess. Um, let's see here. You can also tell that I'm not very skilled with mental math and 0.5. So if we're at 0.5 and we offset that to 0, we take the minimum of that, that's going to be 0. Wait, whoa, hold on. So if we're at 0.5, oh yeah, that makes sense. So yeah, that's definitely not what we want. Because once we get past 0.5, we want to start using these values. So we want to take everything. We want to use everything, all the values beyond 0.5. If I'm at 0.5, that minus 0.5 is 0. And if it is, oh wait a second, what the heck is going on here? You know what? Honestly, at this point, I'm almost 90% sure that I was having like issues like intuiting what I needed to do. And so I was just like, you know what? I know that I know intuitively that I have to invert something. I don't know how many things that I need to invert because like there's obviously, you can see there's a symmetry here. So just based off of that alone, I know that I have to invert something. I don't know intuitively how many things I need to invert. I could only need to invert one thing. I could need to invert two or more things. I don't know. So at this point, I honestly think that I was probably just like, okay, you know what? I think I'm just going to try inverting the sign, and then also take the opposite of this min function and do max. And yeah, that did the trick. There's certain things that's like easier for me to think about, and then there's some things that for some reason are difficult for me to think about. I don't know. It's kind of weird, but there are like I guess patterns maybe that your brain can easily latch onto more than like uh, keeping more than a few numbers in your head and trying to reason about them that way. There's at least situations where you can go, okay, I recognize that there's a symmetry here between this thing that I already have and this thing that I'm trying to achieve. I acknowledge that there's got to be some kind of sign change somewhere, or some kind of inversion of a function somewhere, but I don't know exactly where. And if you get to that point, I mean, it doesn't hurt to just start flipping switches, and you know turning dials and seeing what happens, you know. But anyway, so now we got it. Like we have a single continuous curve that we can use to map the UV components to this new curve that will start stretching. That will give the appearance to start stretching the texture pixels as they get closer to the center, and then start tapering off as they get further from the center. So that is excellent. So now we can literally just add them together. Um, yeah, and again, the reason why that works is because all of the y components on the left curve are are zero for values for values of x that are greater than 0.5. And then similarly for the right curve, all of the y components or whatever are zero for values of x to the that are less than 0.5. And then we're just multiplying the sign of whatever those values were by the curve itself. So it's going to be either 0 or 1 times the curve, which yeah, and then basically just uh, composing the two functions using addition at the end. So yeah, this is our final curve. What was I doing with this? Oh yeah. So after I have the curve, now I basically have like this sort of static bulge. Um, I kind of have this static bulge in the middle of my texture. It doesn't move or anything like that. It's just you can see as it gets toward as the texture gets closer to the middle, it gets stretched out, and that's what I wanted. It doesn't look perfect because like we're going by like one UV component, like one dimension at a time, so you kind of get like it kind of looks a little bit like the stretchiness isn't like a perfect circle. It doesn't look natural. It's kind of squarish, if that makes sense. It might make sense once I actually switch to in-game, but we'll see. But then I wanted to obviously like make because I'm making like a water effect, so I want to make this curve move around a little bit, make the water sort of go up and down, like toward your face basically, as you're looking down at it. I basically put together this little curve, which basically um, oh boy, what was my reasoning behind this? Okay, so I have this oscillator. Yeah, because I'm using sine, so it obviously cycles between -1 and 1. What am I doing with it? Cycles between -1 and 1, and then what was C again? C is just my overall curve. Um, and I think I am C minus L. Why are we doing that? Why are we doing that? Oh, great. I won't see it unless there's values of I that aren't 0. Oh boy. Okay, well, I'm not gonna lie. I can't remember my exact thought process was behind this, but the goal was basically to make this curve oscillate back and forth between each side of this line.